Banu, and we are on chapter 2 atomic structure, and the topic for today's discussion from chapter 2 is shells and subshells or orbitals. So students, after completing this topic, shells and subshells are orbitals, you are quite familiar about it in previous lecture. You will be able to describe orientation, or you can say the rotation, the shape of the S, P and D atomic orbitals. How many orbitals are in S, in P, in D and F orbitals. And I will just quickly recall you from the previous lecture that was about quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. And you know, in the principal quantum number, that is also called that is represented by n, and that shows the size of an atom, and they show the shell or orbits are energy levels. And if it is first shell, then it is k, represented by k. If it is second, L, and so on, m, n. And every shell has further subshells. Like in the first shell there is only one subshell, that is the S subshell, while in the second there is S and P subshell. In the third it is S, P and D subshell, and in the fourth that it is S, P, D and F subshell. So S, P, D and F, these are the subshells. K, L, M, N are the shells, S, P, D and F are the subshells. And in every subshell have orbitals, different orbitals. Like S has only one orbital, it means S is the orbital as well, this is the subshell, and as well it is the shell. While in P orbitals while in P subshell there are three orbitals, that are Px, Py and Pz, and these X, Y and Z are due to their orientation, and these are represented by magnetic quantum numbers. Magnetic quantum numbers tells about the orientation, or you say the orbitals of the shells, subshells. And while these subshells have 5 orbitals, while F has 7 that are complicated, and each orbital contains maximum 2 electrons, and these 2 electrons they spin around their own axis. Out of them 50% have clockwise motion, that is represented by arrow up, and 50% have anti-clockwise rotation, represented by down arrow. So this is a quick review of the quantum numbers that shows the position of the electron in an atom. So today we will learn what is the shell or subshells or orbitals. So shells, basically shell or orbit or energy levels. These are the circular path in which electrons revolve around the nucleus are called orbits or shell. So these are the just path. We consider these are the path on which electrons are revolve. These are called the orbit or shell. So you can define the orbit from here. An orbit or shell consists of orbitals or subshells. So every shell has further subshells. I already told you, and in detail we will discuss in this lecture. And then the cloud showing the probability of finding the electron around the nucleus, that is called the charge cloud, and that area is called the orbital, or you can say the space around the nucleus where probability of finding the electron is maximum, that is called orbital. Like that, this is the S orbital. So around the nucleus where probability of finding the electron, you know electron, now we come to know that electron moves in a wave like motion. So this one, or if electron is here, if it is moving around this like a wave like motion, so the area, this one or this one, where probability of finding the electron is maximum, or this electronic charge you can call, this is called the orbital. So the space around the nucleus where probability of finding the electron is maximum, that is called the orbital. And the between two orbitals where probability of finding the electron is 0, that is called the nodal plane or nodal space. So now come to the shapes of the orbital. What are the shapes of the orbital? You know, S is a shell, it is a subshell, and it is also an orbital, because S has only one orbital, that is represented by only S, and it has maximum 2 electrons. So S stands for sharp, and it has the spherical shape. And Earth's orbital is spherical and symmetrical in shape. And as the value of the n increases, the size of s orbital increases, like this. And the probability of finding the electron is 0 between two orbitals. I already told you. So this plane is called nodal plane. I will explain it again. This is one s orbital. So n stands for first shell, that is k shell, or you can say n is equal to 1. And you know, this is the nucleus, and here it is axis. This one is x-axis, this is y-axis, and z-axis is out of the plane. So we draw this in this way. So this is called z-axis, and this is spherical symmetrical, and probability of the electron around this nucleus on x, y, and z-axis in this area is, this is called the orbital. So s orbital, where the probability of finding the electron is maximum, this is called the orbital. And in case of s, this is the spherical shape. And when it is 2s orbital, so this area is for 1s, and this area will be for this area for 2s. And the space between 1s and 2s, where probability of the finding electron is 0, or you can say nothing, this area is called the spherical node between 2s and 1s, and the size of 2s is greater than 1s. So this is the size of 1s, and this one is the size of 2s. And when this is the 3s, when the shell is orbit number is 3, this one is the 3. So 3s, and this area is for, like say, this is for 1s, this is 2s, and the space between these two shapes, this is called the nodal plane, spherical node of 3s orbital. So size of 3s is even greater than 2s, and these are spherical symmetrical around the nucleus, in space around x, y, and z axis. So this is the s orbital shapes. Now come to the p orbitals. P orbitals, p subshell have 3 p orbitals, that are px, py, and pz, and their orientation in space is on x, y, and z axis, and they have dumbbell shape. And I will show you their orientation, because they are of the same energy, they have same energy level, they are called degenerate orbitals. Like px, first of all, students, you have to draw the axis, and you know, this is x-axis, and this one is y-axis, and z-axis, you know, it is the out of plane. So we draw like this. This is z-axis, and you know, and y also, y is in this direction. This I will represent by a dotted line. This is y dash, and the opposite of this x is the also x axis by x dash, and for z this is z dash. And for px mean this dumbbell shape is on x axis, on the x axis, like we have this x axis, so you have to draw dumbbell, this one. So px has this like shape. So dumbbell shape is on the x-axis. This is px. Similarly for py, this is x-axis, y-axis, and this one is z-axis. And opposite of this side is x dash, and this side is y dash, and on this side is z dash axis. For py first, this will be on y-axis, like this, dumbbell on y-axis. So this is y-axis. Similarly for z-axis, this is y, is x, and opposite of is x dash, and opposite of this is z dash, and of this is y dash. For PZ, of course, this dumbbell will be on z axis, like this one. So Px, now electrons revolving is like dumbbell shape. Electron revolve around this path, and here where is probability of the electron is minimum, this is called the node, this one, this area. And because they have just changing their orientation, they have the same energy and they have the same shape, these are called degenerate orbitals. So if you are asked to define the degenerate orbitals, you can say the orbitals which have different orientation but equal in energy are called degenerate orbitals. So Px is on x-axis, Py is on y-axis, and Pz is on z-axis. And this one orbital can contain maximum 2 electrons with 2 spins. One will have clockwise spin, another will have anti-clockwise spin. And for d orbitals, d subshells have 5 d orbitals, and they are like double dumbbell shape or sausage like. They also have dumbbell shape, but these dumbbells are in some cases double dumbbell, and they can move in the 5 orientation I will draw for you. And in the magnetic field, these are also called the 5 degenerate orbitals. First, be careful. You can draw the axis, or you can draw the dumbbells. Then you can go for the axis. In either case, you can write. First, we have dxy. Dxy means double dumbbells are between x and y axis. So first you can draw x, y, and z axis. This one is x, this one is y and z. So, and in this direction this is x dash, in this direction this is z dash, and in this direction this is y dash. XY means dumbbell shapes or orientations are between x and y. Select x and y. This one is x and this one is y. So draw one dumbbell between in this xy and other. Now this x and this y. Draw other dumbbell between again x and y axis. This is between x. It is not on the z axis. Actually this is between x and y, because they are like pointing here. It doesn't mean this is on the z axis. These are because they are out of the space, and on the papers it is difficult to impossible to draw that are out of or inside the plane. So we have to draw like this. But these dumbbells, these are between x and y. Again this is x and y, like this. So this is dxy. For dy, like yz, you can call. Again draw like these axes, this x, y, and z, and in this direction there will be z, and in this direction will be x dash, and in this will be y dash. Y and z. Select the y and z. So this is y and z. Again this z and y and z and y. So first draw between z and y. This one between z and y. Okay, one dumbbell, and other is between. Now select z and y. This one. So these are between z and y axis. This is not on the x axis. This is between y and z axis. So yz mean between two dumbbells between y and z. Similarly dxz. Third one is dxz. Again draw like x, y, and z, and also there z dash, x dash, and y dash. This is xz. It means now dumbbells are between x and z direction. So this is x, z, and x and z. First draw in between them, and this is also x and z. So other will be between x and z. So it doesn't mean this is on the y axis. This is actually between x and z. So these three are between the axes that are mentioned with their name. while the fourth one, that is dz square, again like x, y and z, and on this is the z dash, x dash and y dash. In this case this is determined different than the previous three. In this case now dumbbell is on the z axis, we have this z axis, and in this case this is extended between the center like this one. So electrons revolve in this way on this. So a z axis like dz square is like a dumbbell, but this dumbbell is extended from the center like this. So these previous three are between the axis, while dz square is on the z axis but extended from the center. And the last one is dx square minus y square. This is very easy. Again draw like x, y and z, and opposite of this x dash, and this is z dash and this is y dash. This is for dx square minus y square, and this is also on the x axis and y axis. This is double dumbbell, one is on x axis and one is on y axis. So select the x axis, this one dumbbell, and now select the y axis. So this one is y axis. So two are on the axis while three are between the axis. So total are 5, 1, 2, 3, 4 and this 5. These subshell have 5 orbitals, and each orbital contains maximum 2 electrons, and each electron has either clockwise or anti-clockwise. If one is clockwise, then other will be anti-clockwise speed. For F, F subshell have 7 orbitals, but these are complicated to draw. Now this is the example for you. If you have understood the 4 quantum numbers as well as these shapes, you can solve this example very easy. Describe the allowed combination of the n, l and m quantum number when n is 4. When you have fourth quantum number, like the spin quantum number, n value has 4, what will be the value of l? What will be the maximum value of m and l? How much possible values? This will be explained with the help of this table. When n is 4, L will be n minus 1. Of course, this will be the 3. When there is 3, then magnetic quantum number has plus 3, plus 2, plus 1, 0, minus 1, minus 2 and minus 3, total 7 orbitals. And lower than this will be 2, with 2 it is 5, and with 1 it will be 3, and with 0 it will be 1. S, P, D and F. So when n is 4, it has 4 subshells, that is S, P, D, F, and the quantum for F magnetic quantum number it will be 7, and for D it will be 5, and for P it will be 3, and for S it will be 1. Question is what is the difference between orbit and orbital? First you can give the differentiation with by their definitions. Define orbit and orbital. Orbit is the space or the path around the nucleus where electron revolve, while orbital is the space around the nucleus where probability of finding the electron is maximum. So second point you can give, the concept of orbit was given by Bohr, and the concept of orbital was given by Schrödinger and by quantum theory, quantum mechanics theory. And the third you can with the reference to the number of electrons. Number of electrons in orbits maximum can be calculated with the help of 2n square, while for orbit maximum number of electrons are 2. So you can give these points while writing the giving the differentiation between orbit and orbitals. This question is usually of 3 marks, that is the short response question. Students, now I will summarize the today's lecture. We have learned about the shapes of s and p orbitals, like this is 1s, this is like 2s, and the 2s is size greater than the 1s, and this is like nodal space. Then the shapes of p orbital, like this px is on x axis, py is on y axis, pz is on z axis, and the space between dumbbells where probability of finding the electron is minimum or 0. This is the nodal plane. And while for d orbitals, I already told you dxy, this is between x and y. In this case, they have first drawn, and then they have write the axis. So you can write in this way, and dx z square is on the z axis with extended portion from the center, and dx square minus y square is on the x and y axis. So this was all about the shapes of the orbital, and our next topic will be the electronic configuration of the atoms. How to write the number of electrons in, how to arrange the electrons in shells, subshells and orbitals.